All right, let's finish up this review. This is going to be we're going to be finding missing parts of the equation, not necessarily probability or z-scores, possibly missing a standard deviation or a mean. And this involves a little bit of algebra, nothing heavy. The first one, number 18, IQ test scores normally distributed with a mean of 100, standard deviation of 15. Find the x that corresponds to the z-score of 2.33. So we're given this information. They want us to find the x. We know that the formula is this. We plug in what we have. And this time we're looking for this value. So we just need to solve this for x. Multiply both sides by 15. 2.33 times 15. That's 34.95, so I get 34.95 equals x minus 100. Add 100 to both sides, and we get x is equal to 134.95. That's the x that corresponds with a z-score of 2.33. Looks good. Number 19. The scores on a mathematics exam have a mean of 76, standard deviation of 8. Find the x that corresponds to a z-score of 2.575. Move this up where you can see it. All right, same process here. We know that our z is formula is found this way, or is that. So we have 2.575 equals x minus 76 over 8. Multiply both sides by 8. Some hand multiplication here. That's the worst part of the problem. That's 40, 56, 60, 40, 6, 16, 20. So it looks like 20.6. So 20.6 equals x minus 76. Add 76 to both sides, and we get x equals 96.6. Hopefully I did that. Looks good. Finally, so you get that 96.6 is the x value that corresponds with the z value of 2.575. Finally, number 20. Assume that the salaries of elementary school teachers in the United States are normally distributed with a mean of 34,000 and a standard deviation of 5,000. What's the cutoff salary for teachers in the bottom 10%? So we have a mean of 34,000. And a standard deviation of 5,000. Now they want the lower 10%, so that's these folks over here. And this is the one problem, and you'll run into this every now and then, where you need to actually use your chart backwards. We know that this area is 10%. That's where the bottom 10% live. Or we could write it as that as a decimal. So what we're going to do is we're going to look up this area, find the z-score that corresponds to here, and then find the x-score, just like we did in the previous two problems, once we have the z. But we have to use this area first to find the z-score. So we want an area that's 0.10000. It's going to be on our negative side because it's less than a half. And you don't always find the exact number, but you look for the one that's closest. So we're looking for something close to 0.1000. And that looks like it right there, 0.1003. The z-score that corresponds to that is negative 1.28. So this z-score is negative 1.28. And we were lucky because they gave us when they said the bottom 10%, that's to the left of the z-score we're looking for. So we were able to use this curve because here again, this always gives us the area to the left. So since we had the area to the left, we were able to just look it up directly. Had they given us the area to the right, if they said above the top 90%, and we were given this area, we would have had to subtract that from 1 first, because before we can use this table backwards, we need the area to the left. But anyway, that doesn't really matter on this problem. So now we have a z-score of negative 1.28, and using our formula, negative 1.28 equals x minus the mean salary divided by the standard deviation, all that's given. And we're trying to find out what salary represents the people, the cutoff for people in the bottom 10%. So we'll multiply both sides by 5,000. Do a little manual multiplication. So we get negative 6,400. Negative 6,400 equals x minus 34,000. Add 34,000. And we get, oh, I don't know, what's 64 minus 34,000 minus 6,400. All this manual arithmetic. $27,600. So the salary cutoff that represents the bottom 10% of salaries is $27,600. So anybody that earns that or less is in the bottom 10% of the teachers, salary-wise, given this data here. And that'll do it. That's your review.